These are packet problems that are preparing you for the test on Wednesday. And I wanted to go over number 4 because a lot of people weren't sure because there's no angle given. How are you supposed to know if it rises 32 feet and this is 470 feet long, what the angle is? Well, you're going to be finding that angle by using what's called inverse trig. Remember that? Inverse of the angle here. So what should we use? Inverse sine, inverse cosine, or inverse tangent? Well, I have opposite and I have hypotenuse. So therefore, I should probably use sine, right? Here's the way you could set it up. Sine of some angle equals opposite 32 over hypotenuse, 470. Does that look familiar? That's kind of like a rewrite from an inverse sine question. That would mean it was inverse sine of 32 over 470. And that tells you an angle. As long as you're in degrees on your calculator, I think we got that figured out yesterday. There was like 6 of you in radians. You've got to change to degrees now. It should tell you how many degrees it is. And I think it's like 2.9. Does that ring a bell? 3.9? Okay. So 3.9 degrees. Ramps, anything with that cars drive on, typically the steepest it'll ever be is a 20-degree angle. You might think that that's kind of wimpy. I mean, 20 degrees isn't super steep, but that's the point. You don't want roads that are super steep because it's really, quite scary if you're going up something super steep. You go off to the side on it, and your car can roll the car really easily. If you're going down it, your car can pick up so much speed that you can lose your brakes can go out. So anyway, basically these degrees will probably be usually pretty small for ramps or for anything on the highway. All right, next thing. I wanted to talk over this one that has a pendulum hanging. Do you get if it has a pendulum hanging down and it swings back and forth? It swings like over to here. It doesn't just swing one direction. I mean, if you have a great big heavy pendulum and you bring it out to the side and you let it go, it's going to swing back over this way too, right? And I hope you get that that's like the edge of a big circle. So that's like an arc. And so what you should have been using here is saying, oh, this is like an arc. So I'm going to use S equals theta R. And I know the radius, they tell me that. It's a 52-foot cable. The radius is 52. And that means this is 52. And that means this is 52. And those are all radiuses. And then this arc distance right here, that's how far it swung. And it tells us that ball swings at an angle of 12 degrees. This is a total of 12 degrees. Why can't I just put 12 right there? Why can't you put a 12 in there? It needs to be radians. Okay. So you change that to radians. Then you put the radius of 52 here. And as soon as you get that changed to radians, you just times that by 52 and you'll have your arc length. Okay. So some of these pictures are a little bit like important and like hard to visualize until you see somebody else help you. All right, I hope you were able to figure these out yourself, but I'm just trying to say I understand. There were some on here that might have been kind of hard. All right, let's talk about this octagon one. I don't need to draw an entire octagon, but I should have the idea that there's going to be a whole bunch of sides like this that would all go towards the center. And this is just one of my little wedges of the octagon. Okay, I'm on number 8. So if you're not on number 8, get there now. And quit farting around with other things, please. Okay, so this angle right here, it may not be immediately apparent, but they've told us the radius was 1, so this side's 1 and this side's 1. I need an angle, and I can't get the angle from using the 1. I need an angle on the side. I've got my side. I don't have an angle, and I also don't have a right angle yet. So what you do is you drop this, and I didn't draw this perfectly. It may not look like a right angle, but that would make this a right angle. Then I've got my little triangle. It's a 1 here. Then I still don't know how many degrees it is. So That's where the genius comes in. If you think about it, a circle has 360 degrees, right? And this has 8 wedges making up that circle. Like if I go to the middle of the octagon, say, imagine this is the octagon, and here's my dot, and I got all these wedges. That adds up to 360, and there's 8 little wedges. So you take 360 divided by 8, and that'll tell you what this total is. Okay, I'm going to grab my calculator and put in 360 divided by 8. .45 degrees. But this little triangle here, it wouldn't be 45, it'd be half of that because we dropped a hypotenuse down and making what's called an angle bisector, splitting that angle exactly in 2. And so that means it's 22.5 on each side. So now, if you take a really messy drawing like this and then you explode it out to the side like this, it sometimes really helps. That angle right there is 22.5. This is the side I don't know. And notice that's only half of one of these sides. Once I do find this x, it's only half of one of the sides of the octagon. And then the radius was this part. That was 1. Once I've got an angle and a side, I can use trig to find anything else I want. And what I wanted to find was x. So I go opposite, and the 22.5 is the angle. So I have opposite and adjacent is what I want to use. So I want to use tangent. Yep.
Make sure you have the one.
Thank you. You're right. You're right. I flipped it in my head as I moved it. You're right. The hypotenuse on this thing is really this side right here. So that should be the one. You are correct. Thank you. So now I'm going to go sine of this 22.5 is equal to x over 1. And so really, 22.5, and then I could times it by 1, but 22.5, sine of 22.5 is my little distance right here. And then I have to times that not by 8. That would be if I had the whole side. First I got to times it by 2 to get that one side that went from here to here. Then that's one side of my octagon. And then I have to times that by 8. All right. I did not do this entire problem for you, but at least I set it up for you. Be wise to pay attention as we go through these. Okay. Now, we've done the first 10. And I've pointed out some ones that I thought were important and hard. Number 9 is another one that a lot of people get wrong because they're not sure how it's supposed to look. I really think too many people start thinking, okay, well, I'm just going to draw a triangle and figure out where to put the numbers. You can't really do that. It's going to turn out to be a triangle, but you have to follow the picture. If it says you're in a plane, then you should draw yourself up in a little plane up in the sky, and you should like have cars on the ground and then draw your triangles to those or whatever. But in this case, it's got the rim of a canyon. Do you get, this is kind of big picture what the Grand Canyon looks like. It's a big canyon. It goes way down, okay? And it says there's the north and the south side. I'm going to call this the north and this the south. You could do it either way. It doesn't really matter. Okay? Now that I know it's talking about a north side and a south side, I hope you get that the triangle is going to somehow be across here somehow. Okay? We got to figure out how. It's actually not like that, so I'll take that out of there. Angle of depression is 19 degrees from a point 7256 above sea level on the north side. Okay, so what they're saying is right here at this spot, you are up from the Grand Canyon like base 7256 above sea level, as opposed to on the other side where it's 19 degrees from there. First thing, you have to remember that I told you to make a line straight across when you're going to do an angle of depression and go down from there. This is your angle of depression, 19 degrees. Do you get that's totally different than a person who drew their triangle like this and put 19 degrees? That will not work. That is not the angle of depression. The angle of depression is from looking straight on, like if the person's head is right here, from looking straight across and then down. That's the triangle you need, not that one. Okay, so I'm drawing my triangle with this angle of depression from straight across down. There's an angle of depression of 19. And the trick really on this one comes down to this spot, 6159. That's here. That's how far it is above sea level, 6159. By telling you that, they've really told you the third side of your triangle. They never told you how far across it was, but now you can tell the blue distance because it's the difference between that and that. You subtract the bigger one minus the smaller one, and you'll get this blue distance right there. Okay, then you've got one side and you've got one angle. You can figure out anything. Do you get if you have two sides, you can also figure out anything? Because if you have two sides, I'm going to just draw it over here. If I have two sides of a right triangle, then I can figure out all the angles and all the sides. If I have this is 8 and this is 10, I can figure out what that is just by using Pythagorean theorem. Or I could figure out how many degrees these are by using inverses. Like, I want to know how big that is. I go tangent of my unknown angle is opposite over adjacent, 8 over 10. And you can do inverse tan to solve that. All right. So I feel like I've kind of identified a few things that you guys were having trouble with, and I want to now do a few practice problems with you to help guide you towards the common misconceptions or try to drive you away from the common misconceptions. All right? I want everybody to start with just drawing a person. That was a person on a stick. There's my person. Okay, start with a person. And I want you to draw me a triangle that shows an angle of depression from that person of 8 degrees. Now I want you to compare it with the person I pair you with. And some of you are going to draw it the wrong way, and you need to know that you're doing this wrong. I'll pause for a second. Okay, I just realized the recorder wasn't running, so I'm going to start this problem again. So you're supposed to be drawing the triangles for this situation. You have an angle of elevation from this glider to another glider. All right, first of all, you draw your horizontal line first. Have to have that first, otherwise you'll get everything all messed up. Now from there, you draw an angle of elevation to that other glider of what? What did I say the first time? 20 degrees? Okay. Estimate what 20 is. These don't have to be perfect, but the better, closer you are, the better. Okay, there. It's looking up to see another glider. Just to keep it simple, let's make that glider just like a dot. Okay, I suppose I can put some wings on it. Okay. Looks like Superman a little bit. Anyway, now that can complete by making a triangle out of it like that. There we go. Do you get that triangle? Now, that glider is kind of flying away from us. They're going faster than us. And we have to assume all kinds of things, like we're assuming that we're holding the same altitude, and we're assuming that the other glider is holding the same altitude. So otherwise, this could get really complicated. But then the second triangle, he's only at, what did I say, 8 degrees? 4 degrees. Okay. Much smaller angle, right? 4 degrees. This is an angle of elevation. Did I say a depression on the second one? Okay. On the second one, I said an angle of depression. I apologize. Okay. Angle of depression on the other one. So of 4 degrees. Okay. All right. The challenge here was just to draw the two triangles. I didn't ask you to like solve anything. Okay, what could we solve? Well, if we held some things constant, like maybe we make this glider just simply descending. Okay, as in it's just floating straight down. Maybe it isn't a glider, maybe it's a, something drifting down like a parachuter or something. If we held that constant, then we could know that those triangles would be the same size like that, and this distance, where they could tell you this distance, but somehow they have to tell you one other side. Can't just tell you an angle. They have to tell you an angle and a side. So what if they said, you can tell by where the person is, where that glider or parachutist, maybe we'll make him a parachuter this time, because then for this context it'll make more sense. We can tell that the parachuter is about a mile in front of us. And this is 1 mile. All kinds of things happen. Now we have to be holding still in our glider, which is, yeah, anyway. I didn't mean to make that an angle of depression, but it's okay. So now if I have one side and one angle, I can figure out anything I want. I could figure out this side right here. I could figure out this side right here. All right, I'm going to give you another one that's more normal where you have your angles of depression, but you could be given angles of elevation or depression. So this one, draw a building. Person standing on top of a building. Okay, person is looking down at another building that's not quite as high. Let's say the building you're on is 1,000 feet high. And you're looking down at somebody who is on an 800-foot building. Question is, if you are able to judge with your iPad's angle measure that you're looking down at an angle of depression, be careful how you draw this now, an angle of depression of, what does that look like? That looks about 25 degrees. Then I could ask you anything about the triangle, because I've given you one side of your triangle, and I've given you the angle of depression. Angle of depression was 25 degrees. Now I'm going to ask you, how far apart are the buildings? Yes, sir. Good question. We are not going to assume he has any height. Otherwise, I hear you, that would affect it. But you're right, and there's all kinds of things that could affect this. If the street was not level, if the, that's why we usually do the heights to these buildings as above sea level, because there's all kinds of things in the real world that would make this much more complicated. But you're right. If I added in his height, the fact that he's above the top of this building, it's going to throw it off. So don't do that. If you want to make it, he's laying down on the building and looking from the one to the other. Okay, then he doesn't have any height anymore. Okay. Now, here's the common mistake. Don't go like that. Why? Because that's not going to give you your angle of depression. That is not the angle of depression. How many of you did it correctly and went like that, your horizontal line first, and then like this, and made that 25? Raise your hand if you did that right. Okay, good. Then you have a chance to answer this right. Now, how do I have a... I told you I gave you a side. I did give you a side. I gave you that side. What is that side of the triangle? By giving you this is 1,000 and this is 800, the difference, that must be 200. So then you can figure out x. Go ahead and do that with a calculator. Use sine, cosine, or tangent, or whatever you need to. Okay, you should have done opposite and adjacent. TOA, tangent of 25. is 200 over x. So to get x alone, I'm going to swap places of these two. In other words, multiply by x on both sides and then divide by tangent of 25. X will equal 200 over tangent of 25. And it'll take me just a second to figure out what that is. Okay, 428, and this is one of those tests where I gotta be picky about units. And I did say feet in the drawing, so therefore it is 428.9, so I'm gonna round it to 429 feet. The buildings are about 429 feet apart. All right. Now let's do another one that's similar, except this time we are going to take into account the height of the guy. And this time it's going to be looking at in the commons. All right, so let's say a person who is about 5 feet tall to their eyeballs, because that's really what you look from, right? Person who's about 5 feet tall is then looking up at the floor of the ramp that goes over the commons. Okay? And we know they're standing at a distance of 30 feet from the ramp that goes over the commons. Okay? So this is 30 feet. How would you know that? Well, if you just pace it off, every pace you take is about 3 feet. And I know that's totally not super accurate, but it's close enough. Okay, so if every pace is about 3 feet, that's about 10 paces out from this ramp that goes over the commons area. Then, the thing we can figure out, if we sight it and we look with our app that we have on our iPad, and we tilt it at the right angle, and we touch save, and we turn and look at it, we can see that it was, let's say, 25 degrees of an angle of elevation. And do you get a common mistake people would make is, oh, so I just solved for x. Kind of, but what did I say at the beginning that was important? He's 5 feet tall. So what you're going to be finding is x, which is the height from the eyeballs up, and then you have to add 5 feet to it. We're going to do that problem right now in the Commons. Okay, so we're going to just pause for a second and go out there. You're going to have your iPad app. I asked you to download yesterday. I'm not going to wait for those of you that didn't do it. And you're going to sight it in. We're going to figure out what 30 feet is, or our best estimation of what 30 feet is from the ramp going over the Commons. We're going to be sighting to the floor that you'd be walking on that ramp that goes over the commons. There we go. Okay, the floor of that, like what you'd walk on, what your feet would be touching. I'm going to sight to that. I'm going to see what angle it is. And then we're going to come back and finish this problem with the real world numbers. If it had been 25 degrees, then we would use what? Sine, cosine, or tangent of this? Come on, sine, cosine, or tangent with the tangent. You'd say tangent of 25, but we're going to figure out exactly what angle that really is. Tangent of 25 is opposite over hypotenuse. No, tangent opposite over adjacent, 30. And we are going to get 30 feet away, and we're going to figure out if it's really not 25. We're going to figure out exactly what it really is. Get the idea how you could actually use this to figure out how tall something is? You just got to know how far away from it you are, and you can pace that off. And you have to have your iPad with you. Factor in that you're about 5 feet tall to your eyeballs. I know it's different for different people, but we're trying to be rough estimate here. Okay? All right, so let's head out there and see what angle it is. Okay, so we're just coming back in from the Commons, and what we figured out in our scenarios was it really depended on the height of the person who was doing it, but I decided we'd coalesce on about 15 degrees there. So if it's about a 15 degrees, now we got to do tangent of 15 and times it by 30. So I'm timesing by 30 on both sides. tangent of 15 times it by 30, and then don't forget to add the height of your eyeballs, which again, I'm going to go with 5 feet just to make it a simple one fits all number. All right, so tangent of 15 times it by 30. Now, of course, now that you understand this process, you could get much more exact. You could measure the height of your eyeballs off the ground in inches. Then you could measure the distance from you to a tree in your yard in inches. And then you could sight it in, get your angle as best you can, and figure out how big a tree in your yard is, for example. Okay, so back to 30 times tangent of 15 times tangent of 15. And that comes out to 8. 30 times, I'm doing that right, yes. 30 times tangent of 15, did you get 8? 8.03? What? Oh, I haven't added the 5 yet. Tangent of 15 is 0.267. I'm going to times that by 30. And then add the height of the eyeballs. Hold on. So, what we were sighting to was about 13 feet high. All right, now let's do our pole out in the street. So we had a pole in the parking lot, and I paced it off and figured out we were about 100 feet away from it. And remember that our eyeballs are like here and our height is like here. So let's say that our height is 5 feet again. Then once again the angle came out to about 15 degrees. But obviously we were much further away from it. So now if we go 15, we want this height here, tangent's opposite over adjacent. So tangent of 15 is equal to x over 100. So we go 100 times tangent of 15. Tangent of 15 is again 0.267. Timesing it by 100 is 26.79. Add 5 onto that. Plus 5. 31. Do you really think that they made that pole 31 feet? Or do you think it was maybe 30 feet and we're off by a smidge? Isn't that more likely? When they make those poles, they don't like make them, let's make it 33 feet tall. They pick a number that's kind of normal. Could be up on a curb, which would add the foot. Maybe it is 31 feet up because it was on a little mound of grass, which is above the parking lot. So yeah, that could count for the foot. So maybe we were more accurate than I was thinking originally. All right, so bottom line is that was about a 31-foot pole, maybe 31 feet off the parking lot. Maybe it's a 30-foot pole. All right, so one last kind of problem that I need you to understand is, do you remember making that octagon just a second ago? Let's make it simpler. Let's make it a square. Draw a square. Now you probably haven't heard of the radius of a square, but if you were to do the radius of a square, you'd go this way. Okay, let's say the radius of my square is 2. Could you tell me how long the sides are? You should be able to. All right, so here's the key. You're drawing this, and you're saying, okay, right angle. The radius is 2, so this is 2 and this is 2. How many degrees is that? Well, it's 360, but there's 4 wedges like this, right? 1, 2, 3, 4 wedges. So that must mean they're each what? 90, right? So this thing here is 90, but we don't really use that one because we're making this right triangle right here. And it would be 45. And that's 2. And then I could figure out x. So I'm going to go, what's got this? That's got opposite and it's got hypotenuse. So it's sine of 45 would be opposite over the hypotenuse. There we go. So x, this little half of a side here, is really times it by 2, times it by 2, 2 times sine of 45. So I got 2 times sine of 45. 1.41. If that's 1.41, then what's a whole side of the square? 2.82. This whole distance must be double that distance, 2.82. Does that make sense? Okay, one more. Let's say that we were sighting to the ground and we were watching something come towards us. Let's say that you were laying on the ground here so that we don't have to factor in your height. Okay, and you're looking down at a bird, and it's walking from here to, let's say, here. At first, your angle of depression was 45 degrees. Then, this angle of depression the next time you took a reading was this green triangle of, let's say, it was 45. Let's say it went up to 60 for the green one. And what could you figure out? Well, let's say we know we're on a building that's 30 feet high. Like the top of our school building would probably be in that neighborhood, a little lower, I guess. Now we could figure out how far the bird traveled from here to here. You'd find this side, and then you'd find this side of the green one, and then you'd subtract them. So if I were to blow up these two triangles, my green one looks, or shrink them actually, my green one looks like this, and it's 60 and 30, and I got to figure out this side. And my blue one would be 45 and 30, and I got to figure out this one. I'm going to call it Y. And one of them is bigger than the other, and I just subtract them. And that'll tell me this distance here, which is the same as this distance here. It's how much bigger the one is than the other, and it's how far the bird moved when it went from point A to point B. Okay, so a few thoughts. Hopefully you're better at angle of depression and drawing those the right way. Hopefully you're okay with the idea of nested triangles like this. You should be able to handle taking a shape and using its radius and figuring out the right triangle involved in that. Now there's all kinds of different possibilities. Remember, there's typically 8 questions on this test. The main general theme is draw a good picture. It's almost always going to involve right triangles. Once you've got a good picture, it's not that hard to do the trig on it. Sine, cosine, or tangent. It's usually tangent or sine. Could be cosine. It's possible too. Okay. Now, the test is coming tomorrow. If you're stressed about that and you want to come in and get extra help, I am available for mass days. Just understand, a lot of kids come in on those days, so I won't have tons of time for you. Do your homework. Check your homework. We agreed as a group that we would have the answers posted tonight right after school, so you can see all the answers to all the questions, and hopefully some solutions too, like how to set this up and how do you set that up, as opposed to just the answers. Okay. So there's a lot of resources available for you to use to study, and these are not incredibly hard, but just generally respect the fact that we are in a tough unit, and therefore, the test is worthy of studying for. All right, tomorrow's a test. Spend your homework time tonight, because tomorrow I won't assign you anything after the test. You'll have the night off. So burn up your time for the next 2 nights. All of it tonight. Yes? Yes, I can show you those scores. That's all I have for the video for today.